All right, let's plow on through. Hopefully we can get through everything. All right, so this is sort of where we left off. We talked about this super function to call methods from the superclass or the parent class. I think you guys probably covered all of this in the workshop time, this like making methods or looking at methods from classes. It's pretty straightforward. I mean, it's just like a normal function, except for the presence of this sort of implicit self argument, which gives you access to the class itself. So I'll emphasize again that the power of classes is all in this self thing. That's the real trick about classes and objects, is this self parameter, which allows you to, basically you can think of it as your class method. It's like a function, it's like a regular function, except for you have this self place where you can store stuff for later usage. That's one way to think about it. That's how I like to think about it. So in this drive, like when you call this drive function and say, my car dot drive 60 miles an hour, then that sets self.speed to be 60. And then in a later function, you can call something else that says, hey, my car dot what's my speed? And it'll just tell you, you can have that function get the value of self.speed and return it to the caller. And so it's a way to, store this stuff for later usage, because you have, in your program, you have this object that you can carry around with you, and it carries with it all of its functions and all of its data. So they're really useful, really useful. All right. So here, you guys saw during the working time that this is the way that you access. So this is, again, I'm not sure if we say it, but the way you access attributes of a class, and an attribute is anything after the dot, is via this dot notation. So in this case, drive is an attribute of the object car underscore C111, and in this case, it happens to be a method, right? It's a function that you could call. It could also be, I think even, maybe we don't have it, but we'll show it later. But like car underscore C111 dot speed would be that variable that holds the speed in it. And so again, just like a normal function, you call it by giving it the parentheses and any input arguments. It's basically just like a normal function. But this is that tricky thing, is that even though self is in the definition of the method, you don't supply it when you actually call the method. It's a little bit weird. It's implicit. The presence of self is implicit here. It's like basically what Python does is when you have this call, it says, okay, I can see that what's happening is that there's a method call happening on this object, and so it basically takes this thing and this car underscore C111, and it stuffs that in as that first implicit argument. So this is what becomes self. So if you kind of think of it, you can kind of unpack it in your head a little bit, that self and this thing are kind of the same thing. Okay, documentation. So this is a little bit of an aside because this is not really specific to classes, but it's a really useful thing in Python. Sometimes people refer to Python as being self-documenting because of this. And so you guys have probably used the help function to get, basically a description of how to use a function or a description of what a variable is or something like that. Well, where does that come from? That comes from these things here, which are called docstrings. And so it's kind of in some sense, it's like a convention. It's not like a rule of Python, but what happens is that Python says that any string that is in the code right after a definition, right after a function definition or a class definition or method definition, we will consider that to be the documentation for that thing, right? So in this case, you say def drive, so I'm defining this drive method for my class, and then I put, it could be in single quotes. I'm pretty sure it can be in single quotes or single quotes or a single double quote or a single quote, whatever. It just has to be a string. That's the only thing. It's just a string. And whatever you put in there, when you do help drive, it'll just spit out this. That's really all that it is. But it's really useful to do this. So when I write programs, again, remember what I said earlier. When you write a program, don't think of it as writing the program for the computer. You're writing the program for other humans to read it, for your future self or some other person who reads it later, right? So when I write programs, even though a lot of the programs I write, I'm the only one who ever runs them or the only one who ever looks at the source code, I still write this stuff in because it's just good practice and it's really helpful for me because I can then do help on the stuff that I've written and get how was that supposed to work? What was I thinking back 5 years ago when I wrote that? So it's a really good thing to put in these doc strings. This is called a doc string. And you can do that for a regular function. It doesn't have to just be a class. You can do that in the top level of the class. You can do that for all the class methods. There's no such thing as docstring for variables, but there are some conventions for it, how to do it, by using comments. And there's also some conventions that are not very strict about how to format the docstrings. But basically, the thing that you want to put in the docstring for a function, the two most important things are, well, there's three important things. One is, obviously, what does the function do? Two is, what are the input arguments? Like, what is this function expecting? In this case, it's pretty clear, right? You drive is the function, and the speed is like what you want, how the speed at which you want to drive the car. But sometimes it's not so clear, and you want to, especially if it's something odd that needs to go into the function, into the input argument, you want to put it there. And then the other important thing is, what, if anything, does the function return, right? So it's called the caller, the person who calls, or the place in the. We sometimes I forget the word, but sometimes we think of computer programs as people. I do, but the caller is the computer program that's calling this function that will expect something to be returned. By default, functions return none. If you don't specify anything returned, they return none. But sometimes if they do return something to the caller, you should tell the caller what they should expect to see. All right. Okay, we talked about this a little bit, about variable scope. Right? We did that example of where we defined some variables inside of the function and tried to access them, and they weren't there. So this is true in classes where the variable scope this is exactly what we did earlier, right? So this variable is just defined inside of this method drive. This variable, new speed, will disappear when that method is done its execution. When it's executed all the lines of the method, when it's done, any variables that are defined inside of that method just go away. However, this variable, because it assigned it to the class object itself, that will persist. Trouble? Yes, computers can be very frustrating. That is absolutely true. So that, again, that's what I was saying about the power of these classes, is that you can preserve these variables for later usage. Yeah?
What would be the need to make a new variable if it's going to go away after the function is called?
It's just, I mean, you need, when you're writing computer programs, you need variables because you need places to store data. So you need, you know, just think about it in a regular function when you're going to, yeah, you just might need something to hold something temporarily. Yeah, depending on the problem, you need something to hold it temporarily. In this example, it doesn't really make sense because you don't really, you know, this isn't really being used. But, you know, once it's doing something more sophisticated, then you'll find that you'll need a place to store something temporarily, so you make a variable to store it, and then just let it go away when it's done. This is all, you guys are getting some of the newer features in computer programs. And, you know, in older computer programs, like in C, for instance, which is one of the most important programming languages, you had to be very careful about all of the memory you use. So when you define a variable, like new speed or something like that, you had to say, okay, how much memory do I need from the computer to actually store the things that I want to put into this variable? And you have to declare it, and you have to do all of this bookkeeping, and then make sure that you get rid of it when you're done with it, stuff like that. But luckily, newer programming languages like Python make it so you don't have to care about that so much. So you can just, whenever you need a variable in Python, you just define it, put whatever you want in it, and then it'll just go away on its own when you're done using it. Okay. So inheritance, children inherit from their parents, not the other way around. Yeah, object-oriented programming is this class hierarchy. Yeah, this is stuff that we already kind of talked about. Is instance will tell you, you know, is this particular object an instance of a different class, and is subclass, you know, is this a subclass of something else? Subclasses have the methods and variables of their parents, plus any additional stuff. We kind of already went over some of this. Yeah, so the model M object can be considered both a model M and a model C because it inherits from both of those things. It can do everything a model M can do and has all of the same properties. A model C is not a model M, right? That just sort of shows that do you know what a hierarchy means? Hierarchy means that, you know, basically there are levels and there's a sort of directionality. So you can go one way but not the other in some sense. You know, the fact that you are your parents' children and they're your parents' grandchildren, that's a one-way thing, right? Your parents are not your children. Okay. All right, so yeah, so here's just walking through. Well, I guess you guys have kind of already done all of this, right? So, yeah, working on it. Yeah, so just to kind of go through again. So we're defining a model C class. It inherits from object. We're giving it some basic data definitions. We're saying it's got 4 wheels, 2 airbags, and its initial speed is 0. These are all things that are defined initially, and then you know the different methods of your class, when called, can change these things. So yeah, and here's the initialization. So here's an example of a docstring for the class itself, right? And then here's a docstring for the init method of that class. And here you give it some initialization stuff. Say it has a top equals false, license plate, blah, blah, blah. Yep, here are those methods, drive, autonomous drive. All right. Okay, and then here's the model M, which inherits, instead of from object, it inherits from model C. And basically, we don't have to redefine all of those functions. Those methods from the model C are automatically in here now. And so we do redefine the init function because we want the model M init function to do something slightly different than the model C init function. We want it to be mostly similar, so it'll take the license plate, right, argument, and make the license plate variable, but we want to change what the has-top has. And so the way we make the same things happen as for the model C is we do the super call, and then we change the has-top variable to be something else. And then it kind of got split funny, but we add this new method called air conditioning, and then that just, says turn on the air conditioning. Oh, actually, can anybody see what's bad about this? This is a bug in our code. Anybody see what's bad here? Yeah? Exactly. So this thing here, this method, is an attribute of the class, right? So its location is at self.air_conditioning. But then the code inside of that method tries to redefine self.air_conditioning to be a Boolean variable. This would probably throw an error when you tried to execute it. Yes?
So for the students who are not finding the document,
Uh-huh.
we have time limit. So can I have you one by one here? I think we have 4 more people who are not done yet. And Charlotte, I think she doesn't have yours. So yeah, but we need yours too.
I submitted mine, but I don't have any info on what I was doing because I would have to consult when I
It doesn't matter. So this one is super quick. You just need to put your name and your ID and your signature. So it should take 30 seconds from each one.
Which one? Would you like to put in one?
Yeah, you start by me. I don't know by you. They figured out your situation. So it's not really bad. No. But we can continue later. I just need 4 people who just what was the Gmail when I sent it to her? But just basically like you got to sign. So what will be directed to you?
Do you guys have any questions about this at all? You guys understand why this is an error here? Yeah, this is the kind of stuff that when you're programming, this will happen a couple of times, and then you'll be like, oh right, I have to name everything differently, and then you just won't do it again. But sometimes it happens. Sometimes you forget that you named something differently.
You put it in it right there, like under the
This?
Yeah.
Yeah.
What does that like do?
So that's what this super thing does. So basically, the super function is kind of like self.
Oh, it's like self?
It's like self, but it's not exactly self. It's the self of the superclass.
Oh.
So it's saying, give me the init function for the superclass and execute it in, like, right where I am right now. And so, remember, the superclass for this class is model C, right? So this thing right here, super paren dot underscore underscore init underscore underscore, is it is exactly this function, right? It's the model C init function. So this method right here is actually just called right there.
Oh, it's just when you calling something earlier in the code.
Well, it's not just calling something earlier in the code. It's calling it's calling this method from this thing. Okay? But in this case, what the super does is that it's sort of like self, because remember in this method, right? What is this method doing? This is initializing the model C, and it's setting two variables in that class, self.hasTop and self.licensePlate, right? So in this case, the self in this method is for model C. But in our case, when this is called, the self that's inside of that method is actually going to be the model M self. Does that make sense? And so that's a way to have all of the stuff that happens in this function happen in the object that we're dealing with right now. I'm trying to think of a good way to think about it. I have a very visual way that I think about objects as, like I was explaining to you about, like you have the blueprint and it's like you put a sticky note on top of it. Like there's a part of the blueprint that you want to do something different, right? And so instead of erasing the blueprint and redrawing part of it, I'm going to instead put a sticky note on top of it and draw the new part on the sticky note, right? So my new class is the old blueprint plus all of my sticky notes on top of it. And I could just take off all the sticky notes and I have the original blueprint, right? And so my new class definition really is I'm just going to reference the old blueprints and then I've got a bunch of sticky notes and I'm putting them on top. And so that's how I think about it. And this super init thing is like saying I've got a sticky note here, but what I'm going to do is I'm going to pull off the sticky note and look at the blueprint underneath, and I'm going to draw that blueprint first, and then I'm going to put on the sticky note and do some different stuff to it. You know what I'm saying? That's kind of how I think about it. That these classes kind of overlay on top of each other, and they can change what happens in the underlying stuff. Okay, right. And then I think you guys might have gotten this far, but this is how you instantiate those classes, right? So you give the class name, and then parentheses, and then any input arguments. And you can see that these input arguments, that's the license plate number. So these input arguments are the arguments to the init function. So these are the classes, and then what these are called class objects. So these are the instantiated class objects. Car underscore C111, car underscore M111, etc. So once you have these objects, those are the things that you can carry around with you in your program, and they'll retain the state. So if you call car underscore M111 drive 5, that's saying I'm going to take my M111 car and drive it at 5 miles an hour, and then it'll just keep driving at 5 miles an hour. I could have 100,000 lines of code here, and then later on I could say, hey, what is car M111 doing? How fast is it going? And then it'll say 5. Right, so, yeah, so what let's just walk through these. So what is car underscore C111 has top? Is that going to be false? Yes. And car M111 has top is true, exactly. And so given what we did here, what is car underscore C111 dot speed going to be? Remember, no, the M111 drive was set to 5, and C111 set to autonomous drive. So you remember what the autonomous drive method does? Right. So it's 65, it goes 65 plus a random number, I think. Right? And I think
Random number times 65.
times 65, right. So it's any possible number between 0 and 65. Random, this is going to return you, yes?
In functions that sign, you use multiply. How is it set from 0 to 65?
Right. So random, so random is a module that says, give me all of the functions, give me a whole bunch of functions that will do stuff with will give me random numbers. We'll do random numbers. And so this function here, random, says, give me a number between 0 and 1. Any random number between 0 and 1. So, give me any number between 0 and 1, and then multiply it times 65. So, given that, what is car C111.speed going to be? A random number between 0 and 65. And how about M111.speed? 5. And car help for these two things are going to be these help here. All right. All right, so, okay. I guess that's basically it for objects. We're going to go, this is a slightly different topic now. Are there any other questions about objects? You guys have totally internalized everything about objects. I'm very impressed. But feel free to ask me any questions about objects. For what it's worth, I had been programming for like a long time before I ever wrote a class. And I had written a lot of Python programs before I ever wrote a class. It's a kind of an advanced topic, but as you can see, it's not that complicated really when you get down to it. And just to emphasize for the third time, the important part of it is the fact that these objects can carry. It's like the way that we usually refer to it in computer science is that objects preserve state, right? When you execute a function, typically every time you execute a function, it's all fresh, right? It's just taking its input arguments, processing them, and giving you output. If the next time you execute a function, it's completely new, right? It's just looking at its new arguments and giving you new output. It's not going to, the fact that you ran a function once in the past is not going to affect what happens to the function in the future. With classes and objects, though, you can do that. You can have a function such that every time you call it, it is different because the internal state has changed. And that can actually make things kind of confusing, which is why some people don't like object-oriented programming. But in general, people like this and find it useful. But you just kind of have to be careful. You have to be aware of how you're using it. When you start to think of things like, computer games, and you've got, you're running around in some world trying to kill all the zombies, each of those things you're interacting with in the computer game those are objects, right? They have a state. Like, that zombie might have been shot in the head 5 times already. So that might be relevant to how it's going to behave in the future. Yes?
Well, technically, it would be possible that it did not have objects if it was made in a non-object-oriented program, is it?
I mean, you could write it without object-oriented programming, but you just have to, you have to be more careful to carry around with you all. Like, you would have to make a data structure that says, how many bullets does each zombie have in its head, right? And you'd have to carry around this whole data structure. Whereas in the object-oriented programming, you can just make a whole bunch of zombies, and each time they get shot, it changes the state of that zombie instantiation. And then all you need to carry around is those set of zombie objects, and whenever you look at them, you know what their state is. So it definitely makes things easier. I'm a big fan of it because I think it makes things easier, and usually for the computer programs that I tend to write, I find it to be very useful. Okay, so now we're on to a slightly different topic, which is about organizing. Well, this is about reading files. So this title, Organizing Complex Computer Programs into Files, is a very important one. And but we're not going to really get into that today. But Christine is going to go over it later, because this is really important. As your programs get more complex, you're going to want to, you might have dozens of class definitions and functions all over the place, and you don't want to necessarily put them all into one file. But even before you get to that, I guess you guys have only been working with these IPython notebooks so far, right? So that's all nice if you're going to just do a kind of a simple sequence of stuff, but you might want to store parts of the computer program in a file so that you can access it in different ways. And we won't really get into that right now, but I'll talk about how you sort of get started with that process. So right now we've been doing all the coding inside of IPython. But usually what happens is, when I write programs now, I usually just open up a text editor and write the computer code in a file directly. And so these text editors, most hardcore computer programming is done in this way. You basically have a text editor where you write your computer program, and then you have a separate terminal where you execute it and test it out. And then there are fancy things which are called IDEs, which are integrated development environments. And those are places where you can write your code and test it kind of all together in one fancy thing. We won't get into those, but those are something you can explore later. But yeah, go ahead. Yeah. It does, but it's nice to have multiple terminals, so you could have one edit. So you don't have to edit and then quit and then test and then reopen your editor, something like that. Yeah. So the text editors it depends on which. So are you guys? I saw some of you have Windows. Did the computers come with Windows on them?
Yeah.
But you put something different on yours?
No, I actually put mine. I put Linux on an SD card.
Oh, okay. So the different operating systems come with different sort of text editor applications. Like in Windows, there's Notepad. In Mac, there's TextEdit. Sublime is another one. Well, those are, we'll talk about those. Those are for those are for Linux operating systems. So yeah, if you are using the Bash shell, I guess she did talk about Bash, the Bash console a little bit at the beginning, I think. So usually, if you're in an environment where you have access to a Bash console, then probably you'll also have access to these text editors, Emacs and Vim. And Nano is the simpler one, so start there. Yeah.
Just like you mentioned, Emacs and Vim also have graphical interfaces.
They do.
I know Emacs does.
Right. Yeah. Vim has one too. I use Emacs mostly myself. So it's pretty simple to start with these things. You just type the Nano is the name of the text editor, and then you just type the file that you want to edit. And this file could potentially not exist, and then you'll create it when you start the code, start the editor. And then, so usually what you do is this part back here, this .py, is called an extension, and that is an easy way to tell both yourself and the computer what kind of file it is. So all Python programs end in .py. All of them. Anything you write in Python, any Python script, Python module, function, definition, whatever, it's all in a .py. Then different other programming languages will use different extensions. .sh if you're going to write a script, a bash script, .txt for just a plain text, etc. And then there are these commands for. It'd be easier just to try this out yourself, basically. But there are at the bottom of Nano there are some help things, and this character stands for the control key. So if you do caret, sometimes this is called a caret. Caret X will exit the file, exit the editor.
It says there, try not to use spaces. That's because it's often interpreted as different arguments. They usually different files.
Right. Yes.
To avoid that, you use a backslash for the space or for all the brackets.
Yes, those two things are true. Although I still would recommend not putting spaces in file names, just in general. You can just jam all the words together or use underscores. That's one thing that I do a lot, is use underscores in file names and in lots of places. Okay. So this is just an example of, like, open up a text editor, put this in the text editor in the new file, and then save the file, and then you can once you've saved this as a file, you can execute that by doing Python my first Python file.py, and then this code will be executed. Okay. This is not exactly related to organizing your code into files. This is kind of another separate topic. But frequently, you want to save data. You'll want to save some data that you've processed in your code to a file. And you'll then maybe in the future want to read that data out of the file so that you can do more processing on it. And so this is sort of an intro into how Python does file reading and writing, just in general. When you're organizing, this is not what you would do if you're organizing your own code into separate files. This is what you're doing if you're reading and writing data that might be processed during the running of your application. So, how Python handles file reading, opening, and reading and writing is that it uses this open function. So what this is doing is it's saying that it's going to assign to this f variable a file I/O object. I/O stands for input/output. So it's going to open this file from the disk called file.txt, and it's going to sort of make it ready for reading and writing. And so what happens here is it says, okay, take my file IO object, this like data that's on disk that I've gotten ready to read and write from, and says, read all of the lines from that file, just one by one. And what this function does, so notice something interesting here, getting back to the objects. Notice this syntax, f dot readlines. So what is readlines, actually? No. This readlines, it looks like a function, right? But what do we call functions that are inside classes? Methods, right? So readlines is actually a method of some class, right? F dot readlines. That's a lot like my car dot speed. F is an object of a class, right? So this is very much like our object in this class instantiation, right? So open is not actually a class definition, but what it is, it's a function that instantiates a class inside of it and then returns that class as its output. So, but it is, you know, like let's go back up when we instantiated here, right? It looks really similar to this. And that's because it is. It's basically the exact same thing. Remember what I was saying, that everything in Python is an object. And that's exactly what it is here. So this thing that's returned from the open function is actually, that is the object of a file IO class. Actually, and let's see real quick what that actually looks like. Okay. So let's just go down here.
Hey, this looks like the Python anywhere.
It is. I'm just running it. It's basically the exact same thing. It's called. This is called an IPython notebook, and I'm just running it on my laptop. So.
I thought that was a Python anywhere thing, but the TY is currently.
Yeah, it's something different. Hold on. Okay. So, let's see here. F equals open foo.txt. Okay. So, did you guys ever, have you guys ever seen this function type?
Yeah.
Yeah, okay. So let's look at what type F is. Okay, I was wrong about the name, but its type is text, you know, underscore io dot text io wrapper. But notice that how this is named, right? It's got that camel case naming convention, and this is a Python internal thing. So, but this text io wrapper is a class, and so is subclass. Oh no, it's supposed to know what the thing you're asking about is instance. Oh no, that's not going to work either. What is I'm trying to remember the name of the function that'll tell me what the superclasses are. Anyway, can't remember right now. So anyway, but that's a good example of these classes and objects in action. So, but what this readlines method does is it says, read this file and return all of the lines from that file as a list. So read underscore lines is a list. And now that it's a list, lists are an example of iterators. Did you guys talk about iterators? No, maybe not. So I'll just mention this briefly. This is an important concept in Python, is that a lot of things in Python are what are called iterators. And that means that they are things that you can iterate over. And iterating is sort of like counting, right? So I have a list of objects, and it has some number of things inside of that list. And when I do a for loop, it's basically give me each element of that list one by one. So for line in readlines, print line. And so let's look at an example of what that does. So we can do lines equals f dot read lines. Okay. For line in lines, print line. So this foo.txt was just a file that had one line in it, and the contents of that line is high class. And so, actually, it's maybe intuitive more. So you can, if I just print lines. Oh, that's an interesting lesson. Okay, this is actually pretty good. This is kind of the fun of programming, is to explore what happens. Okay, I open this file, right? And remember, I was saying that this is an object, so it might have state in it. So I did lines equals read lines. And then I did for line equals lines, print line, and that printed high class, right? And then I went back up here, and I didn't go back up to this part, but I went here and I executed that again, right? And then I executed this again, and this time it didn't print anything. And lines was an empty list. So why is that?
Probably maybe read lines automatically goes to something.
Not quite. Close, but not quite.
Wait a minute. The read line is probably iterating a variable that says what line it's on, like in C.
You're getting very close. So what happens is that this thing opens the file. And when the file is open, there's a pointer to the beginning of that file, right? And then what this readlines method does is that it reads one line and then goes to the next line, and then reads that line and goes to the next line. And then it does that all the way until it gets to the bottom of the file. And then once it's done, that pointer is now at the very bottom of the file. If I go back and say read lines again, the pointer just says, oh, I'm at the bottom, done. I'm done. There's no lines to read. Right? So this is an example of this F object, which is referencing this file. It has some state in it, right? So this is a little bit tricky. This is the thing you have to watch out for. I executed this function once, and it did one thing, and then I executed the same method again, and it did something different, because the state of the object was different the second time I executed it. That's the power of objects, but it's also can be tricky, right? Because it took me a second to be like, whoa, wait a minute, why does that say that there's no lines in it now? But if I go back up here,
maybe you could remove the pointer.
you can. There is a way to do that. But I'm just going to kind of brute force it. I'm going to say, you know what? Go open this file again. Just forget what I had done before. Open it again. Now, when I do read lines, it says high class again, and then lines is going to have the line that it, again, this is a list. Remember, these brackets are a list. And so this is the line it read from that file. And you guys know what this character is at the end? This weird thing? The /n, which means new line. So that file has high class on one line and then a carriage return. That was a useful lesson, actually. I like that.
What does F look
F will, oops. You don't even have to, because when you print a object, usually what it does is it returns you some string that's a kind of representation of the object, right? And it's usually done in these kind of triangle brackets here, and it says, okay, this is an _io.textIO wrapper class object whose name, and the name is foo.text, that's the name of the file I'm opening. The mode is equal to R, which stands for read, and the mode could be R, it could be W, which stands for write, it could be RW, which stands for read-write, which means I can do both of them. And the encoding is UTF-8, which is a encoding of characters, a way to represent these actual characters in the file as bytes on the, on the disk. Okay. Okay, so similarly, you can open a file and write to it. And in fact, I think this is actually a bug here too, because if you don't, let's go back to here. So if I say f.write, blah, blah. Right. So what happened here is it said, oh, you know what? You can't execute this method write on your F object. Because by default, when you open a file without any additional arguments, the mode is R, which means read. So the only thing you can do by default is read the file. If you want to write the file, then you have to, you do this, mode equals W for write. And then you'll see this, right? So what did I try to do here? I tried to read lines from the file. But then it said, nope, you can't execute that method because your mode is W, and so this file is not writable. No, sorry, this file is not readable, it's only writable. But now, if I go down here, I can do this. And I don't remember what the 9 is. That's maybe the number of characters it wrote. And then I can do F2, oops. Yep, I could do that too. F2 equals open foo.text. So I'm opening it when it's default mode, which is read. And if I do F2.read lines, oops. Oh no, I know why that didn't work. I forgot to do something here. So this is important when you're done writing a file. You have to do f.close. There we go. So this, let's see, I can't remember if this was mentioned here. Okay, so yeah, we should all update this slide. But for this slide, what it should be is f equals open file.text, comma, mode equals W, because I'm going to write a file. And then I'm going to do f.write hello, f.write world. But then before all of that gets saved, I have to do f.close, which closes the file and saves all of my changes. Okay. Then, all right, this is another little side thing that's kind of useful. Sorry, I'm just trying to see where we're at now. Okay. So, okay, this is a little, this is another little thing that is very useful. So sometimes you need to, this is kind of a different topic because this is about matching strings, but it's useful in the context of files because, well, you'll see in a second. But regular expressions, what they are a variety of, programming languages have these different ways that you can match strings. And by matching strings, it means I have, okay, let's go back over here to our, okay. So I have this string here, blah, 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 blah. Let's say I want to match the substring, LAH, okay? So I want to find all of the instances where the string LAH happens in this longer string. And it seems like a weird thing. Why would you need to do this? But it turns out that this is the kind of thing that you need to do very frequently. And one way to do that is with these things called regular expressions, which we won't really go into regular expressions, but it's sort of a language unto itself for how to match characters and strings. But a simpler way to do character matching is with this thing called globs, which is a funny word, but it's the same character matching that happens in the Bash console.